Hi, welcome to the Dummy Programmer. So in this video, we are going to do a variation of the two-sum problem, like I mentioned in the previous video. The difference here, you will see in the problem statement. So what they say is that given an array of n numbers and another number x, which is your target, the task is to check whether or not there exists two elements in array whose sum is exactly x, right? So output is Boolean. You could also return the actual numbers. I mean, it's the same thing. The approach is going to be the same. So why do I say that the approach is different from the previous video, right? This is because they're asking for either true or false as the output, or you could also be asked to just return the numbers which sum to the target value, right? And this becomes really easy because now you have the freedom to sort the array. And if you are able to sort the array, then you can just simply walk from both ends of the array towards the middle, and you can sum both elements that you're pointing to and see if they match the target or not. If the sum is less than the target, then we increment the left pointer, right? Because it's an ascending array. So if you increment the left pointer, the sum is going to increase, right? And if the sum is less than the target, then you move the right pointer to the left, basically reducing the sum so that it comes closer to the target. And we do this until both pointers meet in the middle. Okay, I'll walk you through the code, obviously. So let's take the inputs from here, right? So we have nums array, and then we have target. So in this case, let's say it's -2, right? So do we know that we have -2 here or not? Yes, we have -3 and 2. So like I said, we have two pointers here. This approach is called the two-pointer approach, and it's used in a variety of problems, okay? And this is the easiest problem to understand the approach in, okay? So you have two pointers. Say you have a start pointer and an end pointer. Start pointer points at 0th index. End pointer points at the last number, right? So n-1 index. And then we sum the value at start index and end index, and we compare that value to target, right? Why are we able to do that? First of all, because we have already sorted the nums array in ascending order. That means the number at the first index, which is 0, is going to be the lowest, and the number at the last index, which is n-1, is going to be the highest. Okay, so then that means we can basically calibrate the solution. We can calibrate start index and end index. So start pointer and end pointer until the sum reaches the target, or if start becomes equal to end. Basically, they meet in the middle. That means there are no pair of numbers which sum up to the target. Okay, I hope that was clear, but I think in the solution, when I solve it, it will become more clear. So let's say find pair. Okay, and this is nums array, and then we have our target, which is int, and we return an array of int. So you could return a Boolean, which is true or false, or you could also return the array of numbers. It's the same thing. Approach is not going to change. So, so first of all, let's sort the input array. So this is our number. So to sort it, first of all, we have to make it mutable. In Swift, by default, parameters are not mutable, right? They are passed by value. So we do this, and then we do numbers.sort. We do an in-place sort, and we just do this. I know Swift is very easy. And then you have a start pointer, which points at 0. which points basically here, and an end pointer, which is this. So this will be numbers dot count minus 1. So where are they exactly pointing? So after the statement, actually, the array is -3, -1, 0, 1, and 2. So this is for better clarity that actually after this statement, we are not working with this, we are working with this array, right? And so start is pointing at -3 and end is pointing at 2, right? And so we walk from start and from end towards the middle, which is 0. And we check at each position whether the sum is equal to the target or not. Okay. Let's see in the code, because otherwise may not be clear. So the stopping condition is going to fail if they meet in the middle, right? Now, so what do we do now? So we first of all sum the numbers. I think it's not going to be mutated. Let's sum is equal to numbers start plus numbers end, right? Right. And so now we have to check if sum is equal to target. That means we already found the pair of numbers which sum up to the target, right? So in this case, we just return numbers start and numbers end. Otherwise, we check if target is less than sum. That means our sum is greater, right? So that means we have to reduce this part. So we have to move the endpoint towards the left, because if endpoint moves towards the left, the sum is going to reduce. And our idea is to reduce the sum. So what do we do? End is equal to end minus 1. Else, there's only one, a condition left, because if it's not equal to target and if it's not less than, if the target is not less than the sum, then obviously target is greater than the sum. So then we need to increase, right? So we keep the end pointer where it is and we do start plus 1. Okay. And if start and end reach in the middle and we have not met this condition, if we have not met sum is equal to target, that means there are no pair of numbers in the array. And so we return an empty array here. Okay. Yeah. Let's see if it works, right? Before I say anything, find pair and we pass nums and we pass target. And then let's print a result. Right? And let's see. Yes, we found -3 and 1, which sum up to -2. Okay. And if I change, let's say I change the target to 1. Okay. And then let's see. Then we get -3 and 2, because when we sum them, we get 1. Let's give it a ridiculous value, which we know is not going to work. And we get an empty array because this condition does not complete. And yes, so if you have noticed, we have not used any extra space, right? So we have the space complexity is constant and the time complexity is just ON, because we only walk through the array once. So this is a pretty efficient solution. That's it. Thank you for tuning in. I hope you like the video. See you in the next video.